Okay, it says, let g be the function defined by this thing now. So g is using the formula for f. Is g continuous at x equal -3? Use the definition of continuity to explain your answer. So I've got to use limits. So I have to find the limit of g as x approaches 3 from the left, which means if we're approaching -3 from the left, we're using this formula, which is this formula. That's why I wrote on my paper, find the limit as x approaches -3 from the left of g. It's the same thing as finding the limit as x approaches -3 from the left of f. You wouldn't have to write this. Technically, you don't have to write this either, as long as you recognize that you should be using this formula. Plugging in an x that's really close to -3 says the value of that limit is 4. So as long as you had this limit here, -3 from the left equaling 4, that would be sufficient. Then you do the same thing from the right. Limit as x approaches -3 from the right-hand side of g. Again, you don't need this step here. You just need to look up and use that information. So as x gets close to -3 from the right, that means the value of g is getting very close to 4. So the two limits are equal. Therefore, the overall limit is 4. You don't have to have this statement either. You just need to have this limit is equal to 4. And you have to have that this limit is also equal to 4. If you have those two items, you'll get this point. Okay, now we've got to go find g of 3 because we're trying to prove continuity. So, sorry, g of -3. G of -3 means we must use this formula, which is f. So that's going to give us a value of 4. You don't have to write the f of -3. You do need to then state that the left-hand limit, the right-hand limit, and g of -3 all have the same value. And then you say, therefore, g is continuous at x equal -3. That would get you the second point.